This senior design project is characterizing waste plastic for use as aggregate. It was completed by Joseph Previte, Brianna Rathbun, and Evan States. The advisor was Dr. Gamini Mendis, and the sponsor was Ocean Integrity. Ocean Integrity is based out of Jakarta, Indonesia. They are an ocean cleanup company collecting over 500,000 kilos of plastic each week with the help of local fishermen. Their goal is to repurpose the unrecyclable plastic waste by shredding it and using it as an aggregate in concrete building blocks for low-income housing. The main goal of this project was to determine the maximum amount of shredded waste plastic that could be incorporated into concrete while still meeting the ASTM strength requirements. This was done by first collecting and shredding the waste plastic. Then, concrete cylinders were molded and tested. The data from this testing was used to determine the highest acceptable plastic percentage in the concrete. The secondary goal of this project was to evaluate possible solutions to improve the interfacial adhesion between the plastic and the Portland cement. This was done by modifying the shredded plastic using accelerated weathering and surfactant soaking. Concrete cylinders were then created and tested. Finally, the effects of the plastic modifications were evaluated.
To mold the concrete test cylinders, PVC pipes were bought and cut to the required 20.3 centimeter length. Then the mixed design table shown in green was created by using a 1 to 1.5 to 1.5 cement to gravel to sand and plastic waste ratio. This table helped to determine how much of each material needed to be measured and mixed together for each batch of cylinders. For the initial testing, cylinders were molded using 0, 15, 28, 40, 56, and 82% loading levels of plastic waste. 9 cylinders were molded for each loading level so that there were 3 cylinders for each loading level to test on 7, 28, and 56 days of curing. After the initial testing was complete, the same concept was used to mold the cylinders for the secondary testing.
It was hypothesized that with a 20% volume plastic aggregate replacing sand aggregate and 0.45 water to cement ratio, the concrete cylinders would achieve the ASTM recommended strength of 21 megapascals after 28 days of curing.
This graph shows the compressive strength test data as a function of cure time for the various percentages of plastic incorporated into the concrete. Also on this graph, you can see a 17.2 megapascal minimum requirement and a 21 megapascal recommended requirement. After a full 56-day cure time, up to 28% loading level of plastic achieved the 21 megapascal requirement. Once the initial testing confirmed that a 28% loading level achieved the recommended strength value, several secondary tests were run. The first involved lake plastic to see if environmental exposure had any effect on the compressive strength. As seen in this graph, there was not a major change from the previously used post-consumer plastic. Plastic was also exposed to UV light in a QUV machine in an attempt to radicalize and oxidize the plastic in order to have some interaction with the polar cement. This also did not have a major effect, likely due to limited exposure time. Surfactant was also introduced to act as a compatibilizer between the plastic and cement. This dropped the properties, possibly because of micelle formation hindering the cement cure, or the fact that the surfactant was sodium-based. Lastly, recycled polypropylene pellets were used to evaluate geometry effects, and this decreased the properties since the spherical pellet could not as effectively deflect a propagating crack tip.
In addition to the initial and secondary testing, flame testing was completed to assess how damage done by fire could affect the compression strength of the concrete. Each cylinder was rotated while a flame was held to the surface for 5 minutes. Cylinders with a 28% loading level of plastic were used, and it was determined that the average strength from the initial 28% cylinders dropped to 15.64 megapascals. This equates to a 30% decrease in compressive strength. It was also noted that the cylinders continued to smolder for up to 1 minute after the flame was removed. In conclusion, it was determined from initial testing that 28% plastic aggregate replacing the sand by volume percent is the highest recommended amount of plastic to incorporate into concrete and still maintain compressive strength values required in the ASTM standard. The environmental effects of lake and QUV plastic did not improve the interfacial adhesion and compressive strength of the concrete. Surfactant soaked plastic was below the minimum strength due to it likely hindering the cement curing. The recycled polypropylene pellets were also below the minimum because the spherical shape does not deflect a crack tip effectively. It was also determined that exposure to the flame for 5 minutes decreased the average compressive strength by 30%. Special thanks to Dr. Gamini Mendis for his continuous advising throughout the duration of this project, all of the PLET faculty for project advice, Professor Brian Lonnie for training on the Tinius Olson testing machine, and Ocean Integrity for sponsoring this project.